Hello, my name is Cody Yarbrough, and for the last talk of the day, I'll be talking about fish distribution in Lake Michigan. My advisors were Doran, Ed, and Hong Yan. So first I'll talk a little bit about me. I finished my undergrad at Azusa Pacific University in 2014 in physics. Right after that came here to the University of Michigan, studied environmental engineering and natural resources, and finished those just a few months ago. Outside of academics, I worked as an astrobiology intern for a couple of years with the NASA Ames Research Center in California. I've also had different projects in international development and environmental policy, and then most recently working in stream restoration for my graduate research, developing more sustainable artificial spawning reefs for sturgeon in the Detroit and St. Clair rivers. Oh, and what I'm doing, let's see, so I'm getting married in a few months. My fiance is starting medical school in Chicago, so I'm moving out there, still looking for a job in the Chicago area. All right, so to this project, first talk a little bit about some of the goals that we had in mind going into this project, some of the methods that we went about those goals, and specifically talking about the two data sets that I was working with from Acoustics Data along with the Plankton Survey system. And then where I'll really focus this presentation is on the analysis of the data. So we went going into it at these large data sets, needed to do something with them, and so that was where I focused most of my summer, was in analyzing the data, processing data, developing visualizations, and running some statistics. After that, I'll talk about some preliminary results that we found, my thoughts on future work, and then some concluding thoughts overall. So going into this, some things that we know about fish: they have preferred water temperatures, they respond to water chemistry, they respond to light levels, and they go where the food is. So with all of these factors in mind, we want to find out which of them or which combinations of these factors determine fish distribution. And if we can get a good idea of these relationships, then that will help us to better predict or develop models for predicting fish distribution. All of the data that we collected came from NOAA's long-term research transect just off of Muskegon, from the field station, from NOAA's Laurentian vessel. And as you can hopefully see in this picture, we collected fish acoustics and Plankton Survey system data simultaneously so that we could analyze and compare them appropriately. So I'll talk about each of those, the acoustics and then the Plankton Survey system data. First, the acoustics. Basically, at the bottom of the boat, we have a transducer that sends out acoustic pulses, and depending on what is reflected back in the water column, that gives us information on biomass number density, so how much of what we're seeing is in the water column, biomass size, so of what we see, how large is it, and then combining those together, getting an overall idea of biomass, so a grams per meter cubed or something like that for what is in the water column. And on the right side image, here's a typical, what we call an echogram, so just a visualization of the acoustics data where everything below the red line, sort of the black area, is everything below the water column, and that's just the substrate. Everything above is the water column. And here you see a nice school of fish in the water. For the Plankton Survey system data, like I said, this is running at the same time that acoustics data is running. The top right image is the device that's used, and it moves up and down through the water column collecting data for temperature, zooplankton, chlorophyll, photosynthetically active radiation, or PAR, which is really just a means of measuring certain wavelengths of light penetrating through the water column, and dissolved oxygen. So the device that's used on the Plankton Survey system for measuring zooplankton is called a laser optical plankton counter, and it's a device that just goes along through the water, and it leaves a little tunnel open so that water can run through it, shines a laser sheet through a cross section within the tunnel, and based on the shadows, which you can see at the bottom right image, we can get an idea of what is in that area of the water in terms of small plankton size masses. So that helps us to determine counts of what's in there and also the size distributions of what is in the water. So as with any data, as Logan mentioned earlier, you have to do a lot of quality control before really getting to the work of analyzing your data, and that was the majority of what I spent my time doing, was taking some raw data, filtering through it, and putting it into a format that's usable. So bringing primarily acoustic data in first, what I began with doing was just filtering out the good from the bad. Here you can see the image on the left is an echogram with a lot of background noise, a lot of things that need to be filtered out. The image on the right is cleaned up. So that was what I started off doing, was just cleaning up data. From there, occasionally the acoustics instruments will malfunction or shut off for some reason. And when that happens, that means that we have to either toss that data completely or decide to interpolate between what we have and what we don't have. And so here, what you see is surfaces or different levels of where the bottom of the water column is and how that has been adjusted because of a malfunction in the acoustics equipment. Another thing to consider is that since I'm working with two sets of data, acoustics data, Plankton Survey system data, those are collected differently and they are also reported differently. So that means that we have them coming in on completely different grid sizes, which means we just need to take them and put them into the same grid so that we can analyze each set point by point to make valid comparisons. In addition, the Plankton Survey system data initially doesn't come in any sort of grid. It just comes in a data format with latitude, longitude, depth, and then the value. And so we need to take those points, place a grid on top of them, and interpolate or take multiple points and take averages of them to figure out what is best appropriate means of placing them onto a grid. After we have usable data, the next thing that I did was start to develop visualizations of all of these parameters. So for every parameter, Greg Lang already has a series of visualizations developed for the Plankton Survey system. But for the acoustics, we didn't have much for that yet. And so this was one of the things that I did, was just develop a means of visualizing each of the parameters. And here on these graphs, you see on the x-axis, you have longitude, the y-axis depth, and then everything in between is the value, where the white is the bottom of the water column and substrate below that, and everything above is the data. So like I said, there are 14 different parameters to look at, and there are quite a few of them. So going into this, you see, all right, I have all of these variables, and not only do I have these different environmental and biological parameters, I also have other ways of separating the data by region, whether we're looking at epilimnion, metalimnion, hypolimnion, we're looking at the time of the day, the month the data was collected, the depth that it's at, distance. We have a lot of different means of separating the data, and a first step is really just to figure out, okay, where do we go? How do we figure out a way of determining a relationship between all of this data? And there are a lot of different things that could be tried, from making regression trees, spatial cross-correlation plots, just making scatter plots between two variables, trying to develop a relationship, looking at time series, running regressions, and all of these things were things that I did, but not all of them were useful. So the things that I will talk about mostly in this will be regression trees, and Pete talked about regression trees a little bit earlier, and basically they're just a way of taking a lot of data in one variable and seeing how other variables influence that data and can separate out distinct groups within that data set. So here, let's start, for example, with acoustic biomass. So if we want to look at total acoustic biomass within the water column over all of our data sets, we will compare those to the other data sets that we have, and using analysis of variance, which is the method that I used for regression trees, compared them to see which variables or which parameters would come out most significant or potentially most significant for dividing distinct groups within this data set. And so in this example, what I saw was that PAR, again, photosynthetically active radiation, was the first sort of divider in this data set. So if you're looking at PAR greater than 28.9 micro Einsteins per meter squared per second, then you have one distinct group. And if you're looking at a PAR of less than 28.9, then you have another distinct group. And you can do this again and again, continually splitting data up, and eventually you just get these groups of data with different means, and based off of what you see, you can try to determine which groups may be most relevant for whatever you're trying to find. And so in this case, what I saw was that the first potentially most relevant variable was PAR. So we'll continue with that example, looking at acoustic biomass and its relationship to PAR. So first, again, just looking at visualizations, looking at each parameter and how if we can just look at these plots and determine a difference visually, then maybe we can figure out another way of going about analyzing the data from here. So on the left we have acoustic biomass, on the right we have PAR, again longitude on the x-axis, depth on the y-axis, just looking at an overall cross-section of our transect. And sometimes it's easy to see clear relationships. In here we see maybe some more acoustic biomass activity in the deeper regions, and when we're looking at PAR, we don't see a whole lot of light penetration down in the deeper regions. So maybe there's some relationship with that, maybe not. And so we will plot some different parameters, mostly just looking at the mean, median, standard deviation of each of these variables within the regions. And so now we have, on the bottom two plots, I'm plotting regions. So if you can see in the top, you see regions 1 through 6, where regions 1, 2, and 3 are in the epilimnion, regions 4 and 5 in the metalimnion, 6 being hypolimnion, and then separation from nearshore to offshore, and then somewhere in between. Just looking at these regions and what we might find just from plotting mean values in here. And with PAR on the bottom right plot, you can see how as you get deeper into the water column, you see less light penetration, just as you would expect. But with mean acoustic biomass within the regions, you don't necessarily see a very clear pattern in the data. And so looking at this, maybe not conclusive, so go on to something else. All right, what else can we find? Let's look at scatter plots between two variables, pairing them up. Now again, looking at PAR on the x-axis, acoustic biomass on the y-axis. Now looking at this data, we can maybe kind of see a linear relationship between something like this, but on the left side of the graph where PAR is near or very close to 0, there's just a vertical line there, and so it only kind of fits part of the data, it doesn't fit everything. And this is the general trend that we've seen so far with the data, is that maybe we can fit part of the data, maybe we can fit the data on 1 month. Right here we're only looking at 1 month, but if we take all the data together, it's hard to develop key relationships between any two parameters. So in summary, what I did here for the summer was to process a lot of data, develop visualizations for the data, run some statistical analysis on the data, and some preliminary results that we have so far are that little correlation between any two variables has been seen so far to help us determine fish distribution within the water column. But as we saw with the regression tree earlier, looking through a lot of these, there may be potential relationships between multiple variables acting on how fish distribution is determined, but that's something to be looked at more later. So for future work, definitely more statistical analysis. What I did was really just laying the groundwork, providing all the data or the data analysis, and then this can be looked at a little more later. Also, what I primarily looked at during my time was data within 2015, and so looking at data outside of that would also be useful. And then another thing to move on is once we develop some sort of relationship, to use this in modeling for better predicting fish distribution. So my major takeaways from this summer were learning a little bit more about just fish, hydroacoustics, and how all of that works, some data processing methods, definitely a lot in R. I hadn't used R before coming, only MATLAB, and so this was a good experience with that. And then many afternoons of Frisbee, helping out my Frisbee game here, some good takeaways. Acknowledgements, my advisors Doran, Hongyan, and Ed were great just in providing me with direction and just making sure I was doing well during the summer. Greg Lang, Dave Schwab, and also Craig Stowe were very helpful with just providing me guidance on developing interpolation schemes or numerical analysis with the data. It's definitely helpful. Also, all the Summer Fellows, you guys are great. Maria and Logan, especially, just helping me out with learning R was a great help. So that is all that I have. If you have any questions, I'd be happy to take them. Thank you.
If you were to throw biology in there, for example, if the particle size of the silk in the Plankton Survey system, I can tell you what the species is. Now, given that information and knowledge of the individual species, you can put together a narrative of what's going on. I think these statistical tools have to be combined with a little bit of knowledge of biology to push this further. For example, acceleration of fluid stuff, the fish migrate inshore and offshore, so different species of zooplankton vertically migrating in water column with trade preferences. If you break it down into the whole species, there's very clear narrative that goes out of it, and statistics can help inform that. But you can't just assume nothing about the system, go in there with some brute force statistical methods, and hope to see the relationships.
No, I agree. I think that was what we started out doing, was just brute forcing. Okay, let's see if we can find something. And then later on, what I ended up doing was binning different size classes of fish. And as you know, we also have bins for plankton size for the Plankton Survey system. So binning those and looking only at those and seeing where are we finding this size fish in the water column with relation to this size of zooplankton. So some of that has already been paired, looking at different variables. I still haven't seen a whole lot, but like I said, there's a lot of data to go through, and so I thus far haven't seen.
Yeah, I think there has to be a conversation between folks modeling and people who design the studies and data science. Isn't it less than the front of this? But I really appreciate the way you organize the data and so this sort of analysis can move forward.
I'm hearing Hank volunteer to be an advisor, co-advisor next year, so remember that. Any other questions for Cody?
Like you had a nice method for removing noise from images. I was wondering how that works. How do you make this signal from the noise?
That was actually one of the only things that I did, one of the only codes I didn't have to write myself. And so that one is built into EchoView, and it's just a signal processing. I don't know if it just uses standard Fourier transforms. You're pulling out certain signals. And so basically you just say, okay, I only want data within this range, within a certain target strength or within a certain fish size, and it pulls everything else out.
One thing everyone for coming, for their attention, and for some great presentations. You guys did a really good job, and it's really exciting to hear about everything you've been working on, and learning, and a great experience overall. And please feel free to provide us any other feedback, or how we can make it better, or and hope that you'll stay in touch. Siler will be sending out surveys to you if that hasn't already occurred. It has. Okay, so we'd love to get your feedback and just continue to improve this program. And like I said, keep in touch with you, find out how you're doing, help you any way that we can. So thank you very much, and we'll look forward to the second round and Baton Rouge.